Hey guys, Brian Beeler, welcome to the podcast. Today we've got Curtis Anderson. Curtis is with Panasas, and Panasas has been a major player in the HPC AI space for a long time, but they've got some new stuff out. They've got an eye towards enterprise, I think. So we'll get into that a little bit more. Curtis, thanks for coming in today, buddy.
Oh, thank you.
Man, I was thinking with all this travel I've had lately that I'm due for a haircut, but I look at you and I feel less less of a need to go get a haircut. You're working quite the mane there, buddy.
Hey, it's kind of like caveman stuff.
So, uh, you and have chatted before, and the last time I talked to you, I had said, "Man, it has been a while since we've done anything with Panasas." In fact, I think it was a supercompute years ago, and if I remember, you guys were using this chassis with all these blades in it, and
Hmm.
the demo was always slide one out. There was a high cap hard drive in there, and then like a little cache SSD or something.
Hmm.
And you said, "Yep, that's what we're doing, and we're doing something kind of similar still with the architecture." But let's start with the box, and then kind of work backwards to use cases and software, because I think the
Sure.
hardware underpinning what you do is pretty exciting. I know you've got the new announcement in May with some all flash designs. So just
Hmm.
kind of run us through starting with hardware, and then we'll build from there.
Sure, no problem. Right. So the most people in the HPC space are familiar with Panasas' product, but over the last couple of years, we've done a major a re-engineering of that product. It used to be that there was a 4U rack mount shelf that had 11 little blades in it, 2 hard drives per blade. And that was a great product. We built that out of necessity a long time ago. What we've done over the past couple of years is gotten ourselves onto industry standard hardware. So we're still an appliance. You buy the hardware and the software at the same time. On the other hand, it comes on, commodity gear at this point. And so the gear itself, there's 2 different types of nodes. You buy a certain number of storage nodes and a certain number of director nodes. Director nodes manage, this is traditional parallel file system architecture stuff. The director nodes handles metadata, storage cluster membership, and maintenance activities, and data scrubbing, and a whole bunch of other stuff. And the storage nodes just store data. So we've got hardware in each of the 2 different types of nodes that are specific to each purpose, right? The directors just have processor, memory, and network, because and they have an NVDIMM in there for a transaction log, because they're magically fast and wonderful.
So is it then each one of those is independent in that if I need to replace or update a storage node or a compute node, I can just yank either one from the cluster, chunk
Yep.
something new in, and be off and running, right?
Yeah. We
In
are we're at absolute scale out, right? That each individual node shares nothing with the other nodes except a network connection.
And so in your model, that's really what's popular now, like a disaggregated model. So
Yes.
all of those nodes can see each other and interact with
Hmm.
each other as need be, right?
Right. Yeah.
Okay, and you mentioned something, and I'm trying to bridge the gap between HPC and enterprise a little bit here. So you said
Hmm.
parallel file system, and that's something that's not native to traditional enterprise storage
Hmm.
and IT admins. They may have it now, or they may be looking at it for AI initiatives
Right.
or HPC initiatives in-house. But how do you differentiate parallel file systems that are common in the HPC world versus traditional block file object kind of stuff that most guys are used to?
Right. So if you're talking a file server serving files as opposed to serving block storage device, a file server, the traditional architecture, you come in over NFS or SMB, and you go to a filer head. You go through that, and behind that are a bunch of hard drives or flash drives or both. Um, but the traditional architecture has just one of those, because it doesn't scale out, it just scales up, the filer head. And so you end up with a performance bottleneck. It's okay for enterprise class storage systems where you've got a couple of hundred desktop clients hitting a file server. But if you've got an HPC cluster that wants gigabytes a second, that's not going to cut it. So back in the day, with the company was Panasas, founded in 1999 with the sort of original granddaddy HPC parallel file system architecture. The quick way to understand this is somebody wants to open a file named foo, we have a piece of software installed on your client, your compute node. Runs under any Linux you can name. We've got a version for it. Um, that will go to one of our director nodes, say, hey, I want to open foo. Director node will hand back, here is a map across all the storage nodes, from 12 up to hundreds or thousands of storage nodes. Here's where you'll find the pieces of that storage node. Sorry, of that file. The file
Right.
is striped across storage nodes. And so you get back this map. And then the client inside your compute node will talk to each one of those and read the file in parallel from all of those different storage nodes. That's why it's called a parallel file system. So that's sort of the nickel tour for why the technology, why it was invented in order to get past the bottleneck of a single filer head and sort of how it works.
Is that most advantageous then with calling large files? So if I want to go get something that's a couple hundred gig or a terabyte file, something massive,
Right.
if I can definitely see in a system like yours, if there's 6 or 8 or 10 compute nodes and they're talking to a bunch of storage nodes, if they're all giving me a little piece and
Mm-hmm.
then I just rebuild it or just assemble it as those pieces come in, for a large file that makes a lot of sense. What happens with a bunch of small files?
The parallel file systems are built for the moderate to large file cases. The Because of the structure, they're not quite as efficient with the super small files, 4 kilobyte kind of, 10 kilobyte kind of files, as a single filer head architecture. On the other hand, we do fairly well at those, and we have special hardware in the storage nodes to compensate for the overheads that come from the scale out support. So for example, in a storage node, we have an NVDIMM for our transaction log. That's a super low latency piece of memory, but it's persistent. We store our metadata on a low latency NVMe drive. So you don't be waiting for metadata to say, well, where am I going to go get this piece of data, or inodes or any of that stuff. We store small files under about 1.5 MB. They live on all flash, spread out across all the storage nodes, but they're on all flash devices across those storage nodes. And then large files, the gigabyte, terabyte size, they live on hard drives, because hard drives are actually good at delivering bandwidth as long as you don't do a seek and then a small transfer.
Right.
So,
For reading or writing large files, they're still quite efficient at that task, right?
oh yeah, yeah.
So
Go ahead.
well, I was going to say, so with your to match the hardware configuration for customer needs,
Mhm.
uh, I know you've got some all flash stuff, you've got some more capacity oriented stuff. Do you have any kind of mix and match, or how do you help your customers understand how to scale, what components to scale? Because it
Right.
seems to me that you could have, they buy you for one thing and you start doing large media files, whatever, which is
Right.
probably a pretty standard use case. And then if they do some adjunct, something with maybe AI or something else, maybe now it's a different profile. So how do they handle, um, picking up more flash if that's what they need, or less, or more, of some other
Right.
component?
So what I described with the storage node, with the different types of storage drives inside it, that is our mid-rank mixed workload box. So it's meant to handle very gracefully whatever you throw at it. If you're unsure what you need in terms of what you have in terms of workload, what you need in terms of performance out of your file system, that's where you start. If you know that you only have large files, we have another product that's optimized for a lot more large files, a little bit less flash. If you know you have a lot of small files or just have a lot higher performance requirements, you can now buy an all flash product from us. It's all NVMe storage. Same basic architecture as the others, but it's all flash drives, and so it's a lot faster.
So, I made you start at the hardware, which probably
Yes.
is not where you wanted to start, but I think that's the easiest, bridge to really
Sure.
understand what you guys do.
Right.
So roll up a little bit now to software. You've got Panasas sits on top, right, and
Right.
is provides management and UI and all sorts of other things. But talk about the software layer too, and how that helps to differentiate what you guys do.
Sure. So let's bridge off of the hardware into the software for a second. So we had a customer that built up a large system out of the old hardware, but this piece of this software architecture hasn't changed. They had 150 director nodes and 1,500 storage nodes. So when we say scale up, we really do mean that there's a lot of scale in this. There's no such thing as a maximum capacity or a maximum throughput in a modern parallel file system. You want more performance or capacity, you just add more hardware. So that's what PANFS brings, is that's why that architecture was built, is for that characteristic. When you're talking about a petabyte or 5 petabytes of data, you don't want to lift and replace, because that'll take you a couple of weeks just by itself. You want to just continually add on storage. So PANFS is really good at scale out. It's really good at performance. It does support mixed workloads well. The software, the traditional HPC storage systems started back when, same time we started, but they focused, like Lustre and BGFS, and well, BGFS, they're new, but the GPFS, they were focused on very high performance, but they weren't focused on reliability. They were focused on high performance. And they sacrificed reliability and ease of management. Generally, those products take a couple of people dedicated to managing them. That same customer that had 1,500 storage nodes, it took one-half of one person's time to manage that the whole installation, right?
Sure.
So we focus on performance with reliability, with ease of management. We had another customer that had a mid-sized deployment of Panasas gear, and they went 8 years with zero unplanned downtime.
Wow.
So we have this enterprise focus. We're trying to meet some of the enterprise requirements, their expectations of ease of management, low TCO, and high performance. While delivering high performance, right?
So talk to me about this though, on the point of all these nodes, right? Because I mean, you've had a background in enterprise storage. You worked at EMC or Dell EMC or some variation before that, and you've been at other traditional enterprise storage outfits or enterprise architecture.
Right.
What was it, in your view, back at this sort of pivot point in 2000-ish, where HPC needed specific, and maybe even, well, not less media and entertainment, because there were some solutions coming online there, but they tend to be so close to HPC in the way they operate. But what was it that was so specific about the HPC need that the big infrastructure guys weren't able to provide something, or did but didn't do a real great job of it?
It's primarily the scale out, right? In history of HPC terms, right? Cray built super big monster supercomputers, but it was a single computer, and that meant your computation, your weather simulation, whatever, just ran on the one computer. In the late 90s, the industry figured out how to do scale out for computation, taking a weather simulation, running it on 1,000 computers that are connected via network rather than just one big machine. And parallel file systems were the act of taking that scale out technology and applying it to storage, because when you need gigabytes per second, you can't get that from a single storage filer head, right? So that was the thing that started the need for scale out parallel file systems. I worked for Dell Data Domain and NetApp, for example. I came to Panasas about 7 years ago, and the reason I came to Panasas is because NetApp was in throes of what's now called C mode, of trying to do a little bit of scale out. They were just struggling. I realized that if you start from scale out, you can build the enterprise features. If you start from enterprise features, it's really hard to slide scale out underneath it.
On top, yeah. So one of the big challenges back then, though, with moving data had to have been network, right? Because you were extremely bound by network. With today's network, I mean, 100 gigs everywhere. I mean, that's sort of table stakes, but 200, 400's not that it's free, but it's not impossible either.
Right.
Does that change the dynamics at all in terms of the need for a parallel file system?
Yes and no. I mean, if you have a small project, then you don't need a large infrastructure component, storage. But what happened is, yes, networks have gotten faster, but so have all the compute engines, GPUs, for example, right? to feed that beast still takes a lot of data coming in. And at the bottom, every storage system lives on top of hard drives and flash drives. And now with PCI Gen 4, flash drives are actually getting a lot faster in terms of total bandwidth than they were before. They did lots of IOPS, but in HPC land, IOPS is not
Yeah, that
really the
doesn't really
important part,
matter. Yeah.
right? And so the parallel file systems are still relevant. It's just that instead of talking about 100 megabytes a second, it's 100 gigabytes a second that people want to access.
Okay. And your space has gotten a little more competitive over time, but it's
Mm-hmm.
not hasn't been from the big infrastructure guys. They've still
Right.
tried to shoehorn in, I think, existing products to go say, okay, well now we put SSDs in our systems. Now we're capable of handling these workloads, which
Mm-hmm.
may be true in some cases, but still isn't going to the same place where you're headed, I suppose, right?
Yeah. One of the big commercial enterprise products, file server, they could handle a couple of mid-sized HPC projects. But if you start talking about more than a couple, or you talk about large file bandwidth as well as small file IOPS, then they start to run into problems, right? Isilon used to be big in the life sciences space, but most of those customers are running out of gas on them. And so there's room at the top, right? We don't go for the super extreme national labs people. Those people want really, we talk about lunatic fringe. We're not the lunatic fringe. There's a whole layer of fringe above us, right?
I mean, their hair must be really long up there, huh?
Oh yeah, it's yeah. So there's a nice middle ground for us, a good business for very higher performance than you're going to get out of a traditional enterprise architecture, but not where you're talking about bespoke systems that are all the high end, the super high end. They're actually building off of open source, building customized storage solutions just for this one computer.
Right.
So
Which is makes a fun press release, doesn't it? And
oh, it does.
probably makes great results, but it's not exactly approachable to the broader market.
Yeah, those people, just to finish it off, that class of customer, their purpose is to push the boundary, and so they do that, and yeah, that's great. But that's not something that no one else is interested in pushing the boundary except them, right? So
Okay. So what is it then that continues? Because you talked about Isilon and you worked at NetApp. Those have been two classical leaders in the media and entertainment space. So
mhm,
if I look at who attends NAB and then who attends Supercompute, it
mhm,
used to be pretty much the same storage guys at both places because they were both talking about large sets of unstructured data
mhm,
with the various spins on those approaches.
mhm.
But it seems to be that there's some separation there now, and that the HPC market is really doing its own thing, and M&E is maybe
Mhm.
doing the same thing it has been. I mean, what do you see there? And do you guys play in M&E specifically much?
There is a niche that we fit very well in media and entertainment.
Okay.
We're doing CGI. That's Linux-based compute of adding graphics to a still frame and then doing it for the next frame and doing it for the next frame. So we can play very well there. The challenge for most storage subsystems in media and entertainment, and the reason you find specific solutions there, is the editor who's running in 4K RAW. That's like a gigabyte a second, that class of performance. And they want absolutely rock solid latency, no variation in latency, very low latency, because they want to scrub through the video. And as soon as they let go, they want it to play with no dropouts and no pauses. That's a requirement that's unique to that market. And HPC file systems weren't structured for that. They were structured for mass bandwidth, not for consistent latency. And so that's the place where we would struggle with the editor, but we take down the requirements for CGI just happily. That's an HPC workload in all essence.
Well, walk through that a little bit because I don't know that that's intuitive. So,
Sure.
what is it about CGI specifically that makes it look like an HPC workload?
Um, you take a frame from the film and you want to overlay a couple of characters, or an explosion in the background. You want to composite all of these different video elements together. So you do that on one frame, and you do that at very high resolution, and you put it on storage. You read up the next frame and all of the media assets, and you do it again. And there's no particular time requirement, and the effects house might line up 100, 200 compute nodes to do that for them. Well, that sounds an awful lot like HPC.
Is it so? It's not so different from predicting weather models and layering where clouds and things are going to be,
It
or
There is a
yeah,
difference there in the sense
okay,
that weather, say you've got 100 nodes that are doing weather, each node needs to talk to his neighbor nodes to find out if wind is blowing in or out of his neighbor node, right?
mm,
There's all the computers are talking to each other in a weather simulation, whereas in an effects house, you don't need to know anything about the frame prior or the frame after. You just do your work and then you move on. So
okay.
that piece, but and computational fluid dynamics and other traditional HPC things are a little bit closer to weather than they are CGI. CGI is just sort of embarrassingly parallel, if you will.
That's a funny attribution to CGI that I don't believe I've heard before, but I will probably never forget. Uh, so, I mean, we talk about a lot of these HPC workloads, and when we're talking to your customers or businesses out there that are doing these types of things. Now, they may not be HPC houses traditionally, but
Hmm.
everyone that produces products is thinking and moving things and building things are all thinking about how to leverage accelerators, whether it's GPUs or something else, to
Hmm.
take their data and have better actionable insights. And so now these guys, I'm in Cincinnati, so we're at the home of like Kroger and Macy's. I mean, they're
Hmm.
very much looking at
Right,
analytics,
right,
especially in these retail businesses where margins are like razor thin. What can we,
right.
and they can't hire anyone. What can we do to deliver better product, better services, better, transportation, better
Hmm.
automated delivery robots? I mean, all of these things, and they're
Hmm.
using their heavy data analytics to get there.
Right.
Does any of that stuff get a little bit closer to the real HPC world?
Oh, absolutely. So in a specific example, we have a large consumer products company is one of our customers, and they gave us example. Well, you want to manufacture a plastic gallon milk jug, and you
Okay.
want to minimize the amount of plastic in there, but you want to make sure that it won't pop if you drop it in the grocery store, right? And so that is a computational fluid dynamics and finite element analysis problem that they run on an HPC cluster connected to our gear.
Hmm.
So there's a lot of, we find that product optimization across enterprises in general is becoming more of an HPC problem. That is drawing the HPC technology into the enterprises. From the other extreme, everybody, 10 years ago, every CIO in the world was saying, okay, what's my cloud story? How can I leverage cloud to my advantage? Now, even more of them are saying, what's my AI story? How can I leverage that technology base to benefit my organization? Um, if you're talking about AI, machine learning, any of that class of technology, um, it starts with a single computer with a GPU in it or an
Hmm.
accelerator of some kind. Then you might graduate to a white box with 4 or 8. Then maybe you go to a DGX box from NVIDIA. But eventually you say, my problem is big enough. I have enough data. I need to scale out. At that point, what's the best practices you use for that? HPC. All of the technology, techniques, best practices, architectures that you use for HPC, you would use for AI and machine learning in those environments where your problem's bigger than any one accelerated node. And so every enterprise is going to adopt an HPC data center as part of that because AI is going to move to the center of the business side of the enterprises as they do all of the business optimization. Um,
Well, yeah, I mean, it's interesting because enterprise, I think, looks at IT expense as an expense,
mhm,
oftentimes. Either
mhm,
have to support VDI users or support a bunch of retailers with POS systems, whatever. I mean,
right.
it's all about supporting and solving problems and is very often not strategic in terms of how can we create business value here?
Hmm.
And now the conversation seems to be shifting, but we look at the investments that just start with the physical and pause the cloud conversation for a second. If
Hmm.
they're going out and buying new servers for a data center, whatever, I mean, the
Right.
most expensive stuff in the servers now is storage, and then if they're going flash, I mean, they're going to spend $20,000 or $30,000 in storage, and that's going to easily be the bulk of the BOM cost on that server. You were
Hmm.
talking about DGX, but any of these servers that have either the socketed embedded GPUs or if they're slotting in 8 cards in like an AI box,
Hmm.
once you make that investment, I mean, those GPUs are
Oh yeah.
order of magnitude more expensive, tens of thousands of dollars for each
Hmm.
one of those things.
Hmm.
Now we've got a problem where we've made the investment, which is fine. We're going to go solve business problems, which is fine. But we've got to keep those things operational 24/7, or
Yep.
else we've
Right.
got hundreds of thousands of dollars of investment just idle,
Yep.
and that's no bueno. So what are you
Mhm.
seeing there? I mean, your HPC guys get it. They've got schedulers. They know how to do that. How does that translate to the enterprise? That if they're going to make the investment in the hardware, that they've got to make updates in other processes to be able to go use these things effectively.
Yeah, no, that's exactly the pattern that we're seeing. Um, in business terms, traditional enterprise terms, you'd stand up your Oracle configuration and you'd size it for, mostly the like quarter end. That's you got to get this done within a couple of days, whatever, right? And you didn't mind if it was idle all the rest of the time because it served its purpose.
Hmm.
But when you're talking about AI and machine learning, yeah, there's so much money involved in the hardware, it has to be busy all the time. Another piece of the puzzle is that the CIO is saying, where's my AI strategy? And it's not just a strategy. It's there, you've got 47 different types of optimization problems or ways you can improve the business. And so you're going to start 47 different AI projects. Every one of them needs to compete for the accelerator resources, the GPUs or whatever silicon you're using. And so that the and I guess the third piece, the final piece of the story, enterprises like cookie cutters. They like recipes. They don't really want to go out and do a research project and create something new. There's too much risk of it not working. They want the tried and true method. Well, the tried and true method for this is call up a person who knows HPC and say, use all your best practices and set me up. Right. So that's why we think that the enterprises are simply going to take it pretty much wholesale and say, okay, I've got my database environment and now I need my HPC environment, set me up and we'll get going.
The getting going thing's tricky though, right? Because it's not a skill set native to most organizations.
Right.
You've got to build this data science team or hire consultants or whatever. How
Yep.
do you see orgs sort of getting into that? I mean, do most of them, like Fortune 500 probably, but as we scale down a little bit more,
Mm-hmm.
if I'm a couple $1 million business, there's still probably room for me to innovate in my processes with AI, but I don't know exactly how to consume that because I'm pretty sure most VARs that service these sort of mid-market customers don't have a practice on data science. Like, how does that work in your view? And I know this is getting way outside of your target, but since you're so close to this business,
Sure.
is there a good way for smaller businesses to participate in this AI revolution?
That um, so it's a big question, right? So two different pieces of background information. So the pool of employees that know HPC is generally speaking shrinking. HPC was there was a large group of people who learned HPC 10, 15, 20 years ago, but they're all getting that workforce is getting older, and so they're starting to retire. All the young people coming out of the university, they're all looking starry-eyed at Web 2.0, right? And they're chasing data science, but data science is using a GPU. It's not building an environment that runs with GPUs,
Okay,
right?
that's a good distinction.
Right. And so, for my practical advice for a mid-sized corporation is try to take the hardware problem off of your plate. Try to find a VAR that will fix you up with some accelerators, some networking and storage. That is a pre-configured environment. So, okay, great. Now I've got that. I don't need to understand how to architect it. I just need to have it supported. Then your trouble is to find the data scientists. Well, the young people coming out of college, that's a hot topic for them. And so your odds are pretty good that you'll be able to find at least one person, maybe two or three. But sort of that's the sort of feet on the ground practical nature of it, right? You
Right.
got to hire the people.
Well, and I guess ultimately, Amazon's making it easier for us to consume these resources in the
It is.
cloud. So if we're not going to hammer it and use it 24/7, now the cloud actually becomes kind of interesting.
It does.
Um, but now you're going back to your more traditional customer, you've got a data movement problem because you just can't throw petabytes easily up and down, and they can do snow whatever, but it's still a lot of lag to move things into the cloud for analysis. So what
Hmm.
do you see? I told you to pause cloud before. You may reopen cloud conversation.
Thank you.
How do you see that plugging into
Right.
both traditional HPC and then what enterprises are doing with AI?
Cloud is you might call it a honeypot, right? It's really easy to use cloud. It's very attractive. It's when you're doing experimentation, it's very low cost. You bring in, a terabyte of data, and they've got a hot GPU, and it's so easy. But traditional public clouds, are not set up for HPC environments. So if you anticipate growing to the point where you're going to need dedicated storage and dedicated servers, you're going to need machines that are busy constantly as opposed to just whenever you fire off a job, then you'll probably find that your cost of doing cloud-based computation is 5 to 7x higher than if you had just bought the hardware and placed it on site. Now, that's one of those decisions that you can put off when you're first starting. So, let me go start experimenting in the cloud. That's the right thing to do, is to start there. But you just keep your eyes open. At some point, the bill is going to be huge, and you're going to say, I need to start thinking about moving off.
Hmm.
Now, if you never get there, great, right? You stay with the cloud forever, and life is good.
What's the enterprise infrastructure guys are trying to push all of their traditional hardware offerings into the cloud as software. Is there a place for a Panasas file system to be consumed in the cloud?
Eventually, yes, there will be, because the philosophically, data is the gold,
Hmm.
and everybody follows the gold. Where is it going, and who owns it, and how can I manage more of it, right? And so, us having a version of Panafest that runs in the cloud is certainly in the future. The challenge is the hardware underlying our software is not built for the scale, the performance, and the latencies that we would need in order to run a traditional parallel file system architecture, right? We had a lot of discussions with the various clouds over time, and one of the product managers here says, "Oh, he was so proud. I can get 12 gigabytes a second out of this whole zone, large assembly of hardware." And my question was, "Great. Can I stripe across 10 of those dedicated to me? Because I have customers who want 120." And he just
Hmm.
stared at me for a while, right? Um, Clouds are huge, enormous, tremendous scale-out machines, but there is a different focus in architecture from HPC deployments to cloud. They
Hmm.
really want to rent a particular machine to 10 people at the same time because those people's workloads are bursty, but HPC workloads are not. And so there's this, how do we adapt PanFS to run on top of that different architecture of hardware platform?
Yeah,
So,
HPC's not necessarily bursty, but I have seen, and I mean, you would know this better than I, that historically a lot of HPC investments, especially at universities, were grant related.
mhm,
So it would be a professor that wants to go do, some analysis on bee populations, whatever,
right,
and they need to
yes,
track the bees and model it and everything.
right,
And the professor would go get a budget of $500,000 secured by
mhm,
some financier, and then would stand up a cluster of stuff just for that project in the
mhm,
absence of all of the rest of the IT
mhm,
in that university or organization, which seems so wasteful because then 3 years goes by, the thing's over, then that stuff's, I don't know, e-waste or whatever it is.
Right.
Now,
Yeah.
I've seen a lot of universities and supercompute this past year, notwithstanding because it was so small, but that have gotten really smart about going to their faculty and saying, hey, if you want to engage in these projects, just get the budget,
Mm-hmm.
give it to us, or essentially
Mm-hmm.
you'll be our customer. We'll provide all the services you need in
Right.
a consumable way that's already stood up. Now, I was seeing that trend a couple of years ago start towards efficiency, especially at
Mm-hmm.
universities. In the enterprise, I suppose they will have less of that problem. But are the universities getting better about managing their investments in HPC?
I think so. We're seeing the same thing you are. One of the challenges that if you go back 5, 8 years, the grant would cover CapEx, purchasing the
Hmm.
gear. It would have $0 for OpEx, someone to actually manage the gear. And so that was a challenge. Now, so that is, I think that's changing a bit, and people are figuring out, well, how can I repurpose some of the CapEx to run it? Can I give it to the shared resource center? The university needs a really large compute cluster and associated storage, and then can they do some financial engineering to get the grant money into that, and then the
Hmm.
researcher uses it. But I see cloud is helping there, right? Because cloud is 100% OpEx. And so if the grant writer includes, I'd like to do this in the cloud, then the grant will come in saying, hey, yes, you can use this money for OpEx, not just CapEx. And then it makes the on-prem cloud, the university's cluster, one of the options as well as a public cloud.
Which makes sense. I mean, that's
Sure.
a more creative way to, I suppose, to go after that. So we've talked a lot about big environments and what's going on at the headquarters of the world's largest companies
Right.
and research institutions, but also we're seeing this massive trend towards edge, inferencing at the edge, a lot of other AI opportunities, data collection analysis, real-time
Hmm.
stuff going on at the edge. Now, your clusters aren't typically that small. So
Right. Oh,
I'm
yeah.
curious, do you guys have thoughts on what's going on there as this proliferates at the edge? And is there a place for Panasas to participate there as well?
So I mentioned that we now have an all-flash version of our storage nodes, and we deliberately set that up as a smaller entry point. So the building block, if you will, is smaller, like 250 terabytes is the minimum configuration. And
Okay.
you can stack them up and grow as large as you want. But we started with a smaller building block because one, flash is expensive. Two, AI projects that want to start on-prem as opposed to in the cloud, they generally start with small amount of data and then will grow once they get toward production. Life sciences projects similarly, they start small, but they'll grow and get bigger over time. The core challenge about the edge is edges are small, right? Putting an HPC cluster at the edge and thereby justifying an HPC class file system. The edge is somebody's phone. The edge is an IoT device that's watching strain gauges on a dam. And so, and inference is inherently less computationally intensive than training. I don't know, by like 3 orders of magnitude less
Hmm.
intensive, right? You do inference on your phone all the time, but you don't do a lot of training on your phone. And so that combination says that Panasas at the edge proper next to IoT is probably not going to be a great fit. Back a layer or two where you're consolidating, I don't know, whatever set of sensors, thousands to millions of these IoT sensors, and you want to do trending analysis and larger processing, then yeah, we would fit there.
I would dispute you on the training because
Okay, please.
on TikTok, I've trained it to show me only race cars and data center gear. So who's the trainer and who's the trainee? Okay.
That's fair.
Uh,
On the cloud,
yeah.
in the social media, you are either paying or you are the product.
Yeah, that's pretty much right. And in some cases both.
Yes,
Uh, I've learned that the hard way. Uh,
me too.
so we've talked about all sorts of fun use cases. Well, fun, thinner milk jugs isn't super
Right,
fun, but
right.
has real business impact.
Yeah, right.
I mean, all these companies have an environmental mission, right? And so now in the current economic state of inflation and the diesel cost to move stuff across the country, in the U.S. anyway, efficiency is getting.
Hmm.
It was already important. Now it's near crisis levels to be as efficient as you can.
Hmm.
And if my product gets a little lighter, a little more resilient, so there's less loss,
Hmm.
longer shelf life, whatever, all these things
Hmm.
roll into serious money. So the thinner milk jugs is cool. We've all seen the models of air blowing over an F1 car and understanding what that means. So that's your
Right.
fluid dynamics bit
Right.
on downforce and how that leads to thousandths of seconds, which at that scale is everything, right? In
Hmm.
lap time. What are some other things that you've seen with your customers or use cases that might not be so intuitive? What's been kind of a standout or surprise to you? I mean, you see this stuff every day of like, oh wow, I didn't
Hmm.
think that we would see that.
Well, so not particularly an HPC problem, but still one of those factoids that just is very eye-opening. In terms of patents in the U.S., the category of patents that has the most number of patents is baby diapers. Most highly patented
Hey, now you're
category of
talking my language. Procter and Gamble, Cincinnati, another one. Let's go.
um, so the other examples of interesting HPC things, of course AI, of course, right? I class AI as an HPC technology, which some people might debate, but um, well, so there's um, HPC, traditional HPC is changing. It used to be, for example, if you talked about the energy sector, what used to be called oil and gas, they were originally setting off charges across a piece of land and using microphones to listen to the reflections. They would understand what was down there and looking for oil or gas or something like that. And so that turned into a very large geophysics simulation to figure out what was down there. Now, if you're clever about it, you can use AI to listen to the microphones and say, I don't think there's anything there, or there might be. It now is justified to go do the geophysics, right? So that's a change that's happening. There was another one I thought of as well.
Well, a lot of these industries like oil and gas exploration that you're talking about that for decades, for since inception up
Right.
till not so long ago, so much of it was intuitive, right?
Yes.
I mean,
Yes.
I watch, in addition to race cars, I'll occasionally watch whatever hunting or fishing shows on Discovery, normally the tuna one, and I'm always surprised that when that little piece of technology on the dash of the boat starts beeping, they know they it's not fancy, but they see the
Mm-hmm.
fish. They know
Mm-hmm.
where he's going. They know what rate he's traveling. They know exactly where the thing's going to be, and
Mm-hmm.
place lines accordingly,
Mm-hmm.
or crab pots or whatever it is. But a lot of the
Right.
stuff that was intuition based historically,
Mm-hmm.
especially around farming. I mean, we don't even have farmers anymore. Those are all data scientists out there
Yeah.
that are looking at the environmentals, taking in all these sources of data, understanding the economic impact. What's the government going to subsidize? Where they want me to grow? What is my
Mm-hmm.
land going to support? What's the weather going to support?
Mm-hmm.
And then just plop the seeds down. And I know I've greatly simplified the art of farming, but it's so much more data driven than it
Yes.
has been
Yes.
historically, right?
Yes. Yeah.
So all of these things, every business process can be looked at, I think, from a data centric view these days.
Mm-hmm. So another interesting example on the other side, that they're called the energy sector now. It used to be oil and gas, right?
Mm-hmm.
But the oil exploration companies are repurposing all of the exploration they did looking for oil. Now they're looking for salt domes where they can inject carbon dioxide under the ground to store it safely.
Recapture of some of the carbon
Recapture, right?
emissions. Yeah.
You capture the carbon from the atmosphere, you got to put it somewhere, right? So, and they believe, I agree with them, they have a good insight of where they could put it,
Hmm.
right? And so I think that there's a lot of that class of surprising uses out there.
That is surprising. That's the first that we hear a lot about air scrubbing and
Right,
whatever, but eventually you still have to put the stuff somewhere, right?
right, right.
All right. Well, this is all very good conversation. I mean, like I said, we've been seeing you guys at Supercompute and HPC centric events for
Yep.
the better part of a decade. I know you've been around longer, but
Hmm.
we've been going to those events for 7 or 8 years now. And I just think it's really neat what happens there and how this is translating to business use cases, enterprise use cases. A lot of people go straight to the nefarious, the tracking of in-store and the all the video analytics that are happening there, and it's real, but I think it's less to try to stalk you and more to try to sell more bananas in more cases than not. But
Yeah.
there's so much going on there. Seeing you guys bring this to to more mainstream use cases too in the enterprise is pretty cool. Um, what if an org's listening to this wants to check out more, learn more about Panasas? What's the best way to engage with you guys and POC or whatever to get going?
First off, just come to the website, panasas.com, right? And go look around and we've got architecture white papers if you really want to dive on the tech. We've got some use cases if you just want to understand how it might work for you. Um, you know, First off, make contact. The
Okay.
sales cycle in HPC has always been long, right? And so we are happy to talk to people. Even if they're not ready to buy, it's like, oh yeah, maybe in a year I'll be ready to buy. So great. Well, let's talk about what your requirements are and understand what you need, what we're likely to have at that point in time, and we'll stay in contact.
Yeah. Okay. Well, cool. Yeah. I mean, check them out, panasas.com. See what's going on. Curtis, thank you so much for your time. Really appreciate it.
Oh, thank you.